Alright, just going to show you this program I'm writing. Let's look at the question. So it says, like, calculate 2 iterations of Newton's method to approximate a zero of the function using the given initial guess. Round your answers to 3 decimal places. And then it's like, initial guess is 1.2, and f of x is x to the 7th minus 7. So let's take a look at the code. So, I've commented out some of the code, but let's uncomment it. And we don't need cubed, we can make the answer equal to x to the 7th minus 7. I'll return that. This one is the other one. And so this function takes in a x, and we're going to calculate x to the 6th, which is x times x times x times x times x times x. And the answer is 7x to the 6th. Return the answer. This one is, so that gives us f of x and f prime of x. And unfortunately this is hard-coded, but I could probably like make this better, but for now I'm just hard-coding it. So f of x over f prime of x is f over f prime of x. And it takes x and x prime, and it just gives you the answer. And then the difference is, we don't actually use this function. I don't need this. I have some output variables to make the columns, and the initial guess that you can change to 1.2 for this example. We start the difference at 1.0 just so it's initialized, and then we set x equal to the initial guess. And then while the difference is not less than, while this does not evaluate to true of the difference being less than 0.001, it will do this loop where we're going to set column 1 equal to x, like that. We're going to set column 2 to f of x, which gets us that result. Column 3 we'll set to f prime of x, which gets us that result. Column 4 equals f over f prime of x, which gets us that result. Column 5 is equal to column 1 minus column 4. So we'll get column 5, and the difference is equal to column 5. Wait, I think I explained that wrong. Column 5 is equal to column 1 minus column 4. The difference is column 5. What we want to get is this minus this. Is that doing that right? Column 5 minus column 1
is the difference. Oh, yeah. We're going to print out the difference because we're looking for this 0.001, wherever it said that. Oh, we'll do that later for the next one. But it works. It'll be useful still.
And if the difference is less than 0, we multiply it by -1 so that all the differences are positive. So that we can just look for, because I don't care if it's the differences between two negative numbers, that the difference is a positive number. That's what I want. I don't know if that makes sense, but that's the way I've done this. It's so that you can find like where the difference is small.
And we just do the output. It'll put the text on the screen. And then after we're done outputting, we set x. We set the x for the next row to the value that was over in column 5 of the previous row. So let's like watch what happens. I hit the wrong button. So 1.2, -3.417, that rounds up. 20.902, that rounds up. -1.63, that's rounded. 1.363, that's correct. 1.36347, that's rounded. 1.739, where am I? 1.7. Oh no, it's slightly off. 364. 1.363. 1.76. I'm slightly off. I wonder why it's slightly off. Let's check this. XQ, x to the 7th. Three, 6, 3, 4, 7. I know why it's wrong. I know why the answers are different is when you do it manually using a calculator, you don't put in to this column this rounded off 3, 6, 3, 4, 7. We're hacking off this rest of the decimal. So when it goes to calculate the next sequence, it's starting with more accurate decimal places. It's got like 2 more decimal places, whereas when you do I did this with my calculator, you get this answer and you round it off. You round this answer off, and then you put it into here, and then you start doing the calculation again with a rounded thing. So it's ever more rounded if you do it manually. So for answering these questions, it might be my program might be, I guess, slightly more accurate because it's not rounding off at the 1,000th digit every time you fill out the information. Like I was doing this with paper before, and then I wrote this program. So that's all for now. I might do another video.